Ever think about how these tiny chips, way smaller than a dime even, end up powering like all the tech we use every day?
It really is incredible.
It's wild, like, thinking that some of these chips travel like literally farther than we do to end up in our phones, laptops, you name it.
Yeah, global supply chains, right?
Exactly. So today we're going deep into the world of semiconductor manufacturing.
Okay.
Specifically, the kind of the evolving relationship between TSMC and Intel.
Yeah.
You sent over some seriously insightful analogies, and let me tell you, the potential for these two titans to collaborate, I mean, it's sparked some serious debate.
For sure. For sure.
So, where do we even begin with all this?
Well, I think to really grasp what's at stake, we got to start with TSMC.
Okay.
They've achieved this level of dominance in chip making, or advanced chip making specifically, that's almost unheard of.
Like they're at the top of the game.
Yeah, they're producing chips using cutting-edge processes that, honestly, other companies can only dream of.
So it's like they hold the keys to the kingdom of high-performance computing.
Pretty much.
But all that power, I mean, it comes with a lot of attention, right?
Oh, absolutely.
And not all of it's sunshine and rainbows.
Right.
So then what?
Well, this dominance, it's given Taiwan a very unique position, globally speaking. Some even call it the Silicon Shield.
Silicon Shield, what's that all about?
It's this idea that Taiwan's control over such a vital part of the global tech supply chain, well, it affords them a degree of protection. See?
Oh, I see.
Like disrupting TSMC's output, I mean, that would send shockwaves, seriously, through the entire global economy.
Yeah, so basically it's like strategic leverage.
Exactly.
But I could see the flip side, too.
Sure.
If the world relies so heavily on one company in one place, I mean, that creates vulnerabilities, right?
Right.
Especially with all the geopolitical tension, surrounding Taiwan.
Yeah.
What happens if something disrupts that flow of chips?
Well, that is the multi-billion-dollar question, isn't it?
It is.
And that's where the U.S. government enters the picture.
Okay, so
under both Trump and Biden, there's been this big push for reshoring.
Reshoring meaning?
Bringing chip manufacturing back to the U.S.
Oh, right, back to U.S. soil.
Yeah, it's interesting. A few decades ago, the U.S. was a real leader in this.
In chip making?
Yeah, but over time, production shifted overseas.
Primarily to Asia, right?
Right, driven by things like lower labor costs, and these established supply chains already in place.
But now
the U.S. wants to reverse that trend.
Okay, so what's the strategy? Are they just, politely asking, or is it, are they playing hardball here?
It's definitely more than just asking naively, that's for sure.
Oh, okay.
The analysis you shared, it highlights some pretty aggressive policies like potential tariffs up to 100% on TSMC chips.
Wow, okay.
And there are initiatives like the Chips and Science Act, which is pumping billions, literally billions of dollars into funding to incentivize domestic chip production and research.
So the message is loud and clear, basically.
Yeah, the U.S. wants to lessen its dependence on overseas manufacturers, especially for such a crucial technology,
100% tariff. I mean,
yeah,
that's a big statement.
It is.
So how has TSMC responded to all this pressure?
That's a good question.
They're not just packing up and moving everything back to the States, are they?
Not exactly, no.
Okay.
They are expanding their presence in the U.S., though.
Oh,
in fact, they're building this state-of-the-art facility in Arizona.
Oh, wow.
But even with these advancements, there's a bit of a catch.
What's that?
The most advanced packaging processes, those crucial for making the most powerful chips, they're still mainly done in Taiwan.
Really?
Yeah, so you have this somewhat awkward situation where TSMC manufactures part of the chip in the U.S., and then they ship these partially finished chips called wafers back to Taiwan for the final stages of production.
Okay, hold on.
Sure.
Back up a second.
Sure.
Wafers. Now, forgive me. I need a quick explainer here.
Okay, no problem.
What exactly are these wafers, and why are they so important?
Right, so imagine a really thin slice of silicon, kind of like a super thin pizza, if you will.
Okay.
That's a wafer.
Okay.
It's the base material onto which hundreds, even thousands of individual chips are built.
So it's like a chip sheet.
Yeah, you could think of it that way, yeah, containing the building blocks for all sorts of tech.
Oh, wow.
And these wafers, they go through this incredibly complex multi-step process.
Right.
And the packaging stage, that's where individual chips are cut out, connected to external circuitry, and basically prepared to be integrated into devices.
Okay, so they ship these wafer pieces back and forth across the Pacific.
Essentially, yeah.
That sounds ridiculously inefficient.
It is.
Not to mention risky.
Yeah,
I mean, isn't that a huge vulnerability in the supply chain?
It is, and that vulnerability, well, it adds fuel to the fire of the U.S. government's push for domestic production.
Right.
It's not just about cost; it's about security and control.
Absolutely. So where does this whole situation leave Intel?
Right.
They were the champions of chip making, weren't they?
They were. Their legacy in the semiconductor world is undeniable.
But
In recent years, they've faced some pretty significant setbacks.
in what way?
Particularly in their manufacturing capabilities, they've fallen behind TSMC, technologically speaking.
Oh, I see. So what's Intel's game plan? Can they reclaim their top spot, or are they looking for a new path?
Well, that brings us to the heart of our deep dive today.
Okay.
The analysis you sent over, it suggests a potential solution, a bold one,
Oh.
a collaboration, maybe even a joint venture with TSMC.
Okay. Now this is interesting.
Yeah.
A chip-making power couple, huh? But is that even realistic?
Right.
Can two companies with such different histories, different cultures even, can they really, just merge their expertise?
That's the million-dollar question.
It is.
And as we dig deeper, we'll explore both the potential and the potential pitfalls of this kind of partnership.
Let's do it. This is where it gets really interesting. Okay, so we've got TSMC, this chip-making powerhouse, and they're facing all this pressure from the U.S. government, to bring production closer to home.
Right.
And then we've got Intel for the top dog, but now, well, they're lagging behind in this tech race.
Yeah.
So the big question is, can this partnership, can it really work? What would that even look like?
Well, it's definitely not as simple as just, like swapping a few engineers and calling it a day, chip fabrication. It's incredibly complex.
I bet.
Almost like an art form, but mixed with cutting-edge science.
Yeah, I can see that.
And each company, over years, decades even, they develop their own unique processes.
Oh, wow.
They've got specialized equipment, they've got proprietary techniques, even their own chemical formulas for etching the chips.
So it's not a one-size-fits-all situation.
Definitely not.
Could you give us a concrete example of what makes this collaboration so tricky?
Absolutely. One crucial aspect is the photolithography process.
Okay.
Think of it like using a super high-tech projector to print these intricate circuitry patterns onto the wafers.
Oh, I see.
Now, TSMC, they've mastered this technique. It's called extreme ultraviolet lithography.
Wow, that sounds intense.
It is. It uses incredibly short wavelengths of light to create these tiny, densely packed features on the chips.
Oh, wow.
Intel's been working on implementing EUV, but they've hit some snags.
Really?
It's not just about buying the machines. It's about having the expertise to calibrate them, to optimize the process, to troubleshoot any issues that pop up.
It sounds like trying to recreate a Michelin star dish just by, reading the recipe online.
Yeah, exactly.
You need that experience, the intuition, like the whole ecosystem of knowledge that's built up over time.
Exactly.
Fascinating.
Even Morris Chang, TSMC's founder, a legend in the industry.
Oh, yeah?
Even he's expressed skepticism about merging these distinct manufacturing cultures.
Really?
He's likened it to trying to mix oil and water.
Oil and water, huh?
Yeah.
So if a full-on merger, like of their manufacturing, isn't feasible, what's the alternative?
Right.
The analogies you sent over, they seem to point to a different approach?
They did. Right. So instead of trying to transform Intel's entire fabrication process, a more focused collaboration might be the answer.
Okay.
The idea is for TSMC to focus on building these advanced packaging facilities in the U.S., potentially in partnership with Intel.
Oh, interesting.
This would address that vulnerability in the supply chain, we talked about earlier.
Right, the shipping of wafers back and forth.
Exactly, bring in that crucial final stage of production closer to the initial fabrication.
Right, that makes sense. But what's in it for Intel?
Right.
And how does this impact TSMC's, silicon shield, that strategic advantage they have?
Good question. So for Intel, this could be a real lifeline.
Okay.
Partnering with TSMC on advanced packaging, it lets them leverage TSMC's expertise.
Right.
But without having to overhaul their entire manufacturing process, which would be a massive undertaking.
Right, of course.
They could tap into, TSMC's knowledge of these cutting-edge packaging technologies.
Like 3D stack.
Where you stack multiple chips vertically to, increase performance and reduce power consumption.
Oh, wow.
So it's a chance for Intel to catch up in this rapidly evolving field.
Right, so a win for Intel, but what about TSMC? Doesn't this move potentially weaken their position?
It's possible.
If they're, sharing knowledge and establishing a bigger presence in the U.S., does that erode their strategic leverage?
It's a legitimate concern.
Yeah.
Some analysts argue that any transfer of knowledge, even in a specific area like packaging, could diminish Taiwan's technological edge.
Right.
There's this fear that it could make the world less reliant on TSMC and therefore potentially weaken Taiwan's silicon shield.
Okay, so it's a delicate balancing act.
It is.
Trying to keep the U.S. government happy, strengthen these global supply chains, and maintain a competitive advantage all at the same time.
That's right.
So what are the potential outcomes here? Could this partnership actually benefit both companies and the global tech landscape as a whole?
That's what we'll explore next.
Okay.
The potential benefits are significant, but so are the risks.
Right.
And understanding those risks is crucial for you, the listener, as you navigate this complex world of technology.
Okay, so let's break it down.
All right.
What are the upsides and what are the red flags we need to be aware of? Okay, so we've talked about the potential of this TSMC-Intel partnership, right?
Right.
Sharing their expertise, specifically on advanced packaging to try and strengthen U.S. chip making and maybe help Intel catch up a bit.
Right, right.
But I keep coming back to the bigger picture here.
Sure.
How does this all impact, global chip supply chains, technological innovation, even geopolitics?
Yeah.
It feels like there's a lot riding on this.
Oh, there is. It's definitely a high-stakes game with implications that go way beyond just these two companies.
Okay, so let's start with the potential benefits.
Right.
Okay, so by establishing a more robust U.S. presence, in advanced chip packaging,
right,
the global supply chain, it could become more resilient,
yeah,
right?
The idea.
Less reliance on just one place like Taiwan
right,
means less vulnerability to disruptions, whether it's, natural disasters or political instability.
Yeah, trade disputes, you name it.
Right, so spreading the risk, basically.
Yeah, diversifying those production hubs.
Makes sense, especially in a world that just seems, increasingly prone to those kinds of disruptions.
For sure.
But what about the economic impact?
Yeah.
Does this shift manufacturing jobs back to the U.S., or does it create, a whole new set of challenges?
Well, it's a mixed bag, to be honest.
Oh, okay.
On one hand, yes, expanding advanced packaging in the U.S., it could lead to job creation, in high-tech manufacturing, engineering, research, and development.
Right, of course.
However, it's not a simple equation.
How so?
The semiconductor industry, it's highly specialized.
Okay.
Requires a skilled workforce. The U.S. would need to invest heavily in education and training to make sure, they've got the talent pool to support this kind of growth.
It's not just about building the factories.
Right.
It's about cultivating the expertise to actually run them.
Exactly.
What about the impact on innovation?
Yeah.
Does this collaboration, does it stifle competition or could it actually accelerate the development of new technologies?
That's where things get really interesting.
Okay.
Some argue that by working together, TSMC and Intel, they could actually push the boundaries of what's possible in chip making.
Really?
Combine, TSMC's manufacturing prowess with Intel's design expertise.
Right.
This could lead to some major breakthroughs.
In what areas?
Areas like artificial intelligence, high-performance computing, even quantum computing.
Wow.
Instead of, constantly competing on every front, they could complement each other's strengths.
It's a sort of competition then.
Yeah, you could call it that.
Cooperating in some areas, but still competing in others.
Exactly.
It's like those rival sports teams that train together in the off season, to elevate your game.
Right, right.
But I still can't shake this question about Taiwan's silicon shield.
Sure.
Does this partnership, does it unintentionally weaken Taiwan's position, on the world stage?
It's a valid concern.
Yeah.
The more knowledge and production capacity that's outside of Taiwan,
Right.
well, the less leverage Taiwan might have.
Right.
However, there's another way to look at this.
Okay.
By diversifying its operations, TSMC might actually be strengthening its own resilience.
Really?
Yeah, if tensions were to escalate around Taiwan, having a good chunk of their production in the U.S., it could act as a buffer, you see,
Right.
ensuring that the global supply of chips, well, it isn't totally disrupted.
Okay, so it's complex with potential benefits and risks
It is.
for both companies and for the world as a whole.
Yeah, for everyone.
What stands out to you as the most crucial takeaway from all of this?
That's a good question.
What do our listener be thinking about as they, process all this information?
I think the key takeaway is this. The world's reliance on semiconductors, I mean, it's only going to increase.
Right.
These tiny chips. They're the foundation of our digital lives.
Yeah, they're everywhere.
Understanding where they come from, how they're made, and the geopolitical forces at play. I mean, that's essential for anyone who wants to understand the future of technology.
It's a good reminder that tech isn't just about gadgets.
It's not.
It's intertwined with economics, with politics, with global power dynamics.
It's all connected.
As we wrap up this deep dive, I have one final thought for you, our listener.
Okay.
What if, instead of, viewing this potential partnership through a lens of fear or competition,
Yeah.
we embraced it as an opportunity?
An opportunity.
An opportunity to forge stronger global partnerships, to accelerate innovation, and maybe even create a more stable, a more equitable tech landscape.
It's an interesting thought.
It's a future worth considering.